Hi everybody, I'm John Shepherd. I'm Emeritus Professor of Earth System Science at the University of Southampton, and I'm also co-chair of the SRM Governance Initiative. I'm going to be talking this afternoon about marine cloud brightening, which is one of the two major forms of solar radiation modification, to be contrasted with stratospheric aerosol injection, the other main form of SRM. There are also techniques called cirrus thinning and surface albedo enhancement that I shan't be discussing in this talk. The purpose is to review the basic features of marine cloud brightening, especially those that are relevant to its governance, so that we are all starting on more or less the same page for this webinar and work from the same effective knowledge base. I shan't be getting into any technical details. The later talks will do more of that. And just for the record, my position on this topic is that as a scientist, I aim for enlightened skepticism for both SRM itself and marine cloud brightening especially. I'm neither an advocate nor an opponent of these techniques. So the context of this is that, of course, we are currently dealing with a new and rapidly evolving global crisis, the COVID-19 pandemic. But unfortunately, another well-known but slowly evolving global crisis has not gone away, and that is, of course, climate change. That will have devastating effects on the health and livelihoods of billions of vulnerable people, especially in the developing world, unless we take effective action. So it also needs urgent, but in this case long-term and progressive transformation of human activities, adaptation to what is unavoidable, mitigation, reduction of emissions to zero sometime this century, and perhaps if these are not enough or not done soon enough, we may need to consider methods for climate alteration, otherwise known as climate intervention or geoengineering. The alternative to effective action is unfortunately excessive human suffering, which I'm sure we would all wish to avoid. So, marine cloud brightening. The method, as the name suggests, is to brighten clouds, and you can do that by making them more reflective, and you can do that by ensuring that they have more or smaller water droplets within them. And you can do that by providing additional cloud condensation nuclei, because cloud droplets don't form all that easily. They need to be supersaturated before they can form, and we can assist that process by providing water-attracting nuclei, small particles that enable them to form more easily, with the same amount of cloud water, not putting any more water into the atmosphere, just these additional nuclei to help the droplets form. But you can only do that where clouds are almost or just actually forming anyway. That means at the margins of places where there are clouds. You can't do it in dry air, and there's no point in doing it in wet air where there are clouds anyway. It's inherently a marginal process on the fringes of major areas of cloud formation. On the other hand, the radiative forcing by clouds is large. If a cloud covers the sun, it can reduce the amount of incoming radiation by 50% or more. So the effect may be both large and highly localized, and that may be either a good thing or a bad thing. Now, marine cloud brightening takes place in the troposphere, the lower atmosphere, less than about 10 kilometers altitude, because that's where the clouds are. And that's a major difference from stratospheric aerosol injection, which takes place at much higher altitude up in the stratosphere. But both of these techniques affect the radiation balance of the planet and so operate quite quickly. But in the case of MCB, the direct effects are quite local, less than a few hundred kilometers. That is roughly the same scale as major weather systems in the natural world. the short residence time of cloud condensation nuclei does create additional problems. They don't last long in the atmosphere. They get incorporated into rain droplets and rained out in a period of a few days to a week. So you would need to replenish the material that is forming the cloud condensation nuclei quite frequently, and that would probably mean that you need to inject quite a lot of material compared with stratospheric aerosol injection. And if you're injecting a lot of material, you'd obviously prefer that to be benign material. So something like sea salt, which we have lots naturally, would be ideal, but it might be something else in practice. So what are the issues of concern? Well, we know that marine cloud brightening is feasible in principle. We can see the ship tracks on satellite images that result from the sulfate aerosol in their smokestack emissions. But we don't know yet whether it will work well enough. It may, in practice, not be possible to produce enough or sufficiently small droplets consistently by spraying seawater, for example. The nozzles may be clogged by the impurities in seawater. We may find that the systems that have been suggested for using renewable energy, sun and wind, on the ships that would be used may not work as well as is hoped. And that means we may need to find alternative methods for producing those cloud condensation nuclei or distributing them. And the materials may perhaps be more toxic than sea salt, or the method of injection may be more expensive than we expect. So these are issues that all need to be researched. When it comes to governance, the direct cooling effects may be quite localized, but the indirect effects on regional weather systems may not be. For we have strong localized cooling that may perturb the track of the jet streams. It may cause semi-permanent modification of planetary waves that drive weather systems around the planet. And that regional impact means that we may need multinational governance, even of techniques that can be actually executed within areas of national jurisdiction. Because the effects may be much more widespread, they may be transboundary effects in an international context. And we need to figure out what organisation would govern these activities that would probably take place on the high seas. Would the UN law of the sea be applicable, even though the modification is actually taking place in the atmosphere? Or would we need to create a UN law of the atmosphere that at present does not yet exist? Would spraying of anything other than sea salt be considered to be pollution and so be prohibited under the law of the sea? And what about sea salt itself? Although that's a natural material, is injecting it into the atmosphere on a large scale an acceptable procedure? So, to reach some conclusions, marine cloud brightening is an intriguing possibility, but it may yet prove that it is not sufficiently effective or affordable or environmentally benign to be considered for real use. The wider-ranging teleconnection effects are likely to be very significant because large localized forcing is exactly what drives natural weather systems, and that all needs to be figured out. It may very well not be acceptable to leave marine cloud brightening to national governments to govern and manage. We may need multinational frameworks, and existing frameworks are not well adapted, so we might need something new. That might take time to create. Perhaps we need a UN law of the atmosphere, or even a new global environmental treaty that goes beyond the treaties agreed at Rio. All of these issues need consideration and need to be researched before we can reach any firm conclusion about the advisability or otherwise of marine cloud brightening. Thank you.